Good morning, everyone. As Laura mentioned, my name is Mark Weinstein. I'm a senior product manager here at Learn on Demand Systems. And this morning, we wanted to talk about building cloud labs using cloud providers and web-based services. Obviously, a lot of the world, a lot of the industry is moving to the cloud these days, and cloud training tends to be a little bit challenging. So we're going to show you one of our available services that we call Cloud Slice that is going to make this much easier for you to build and effectively maintain and secure cloud labs. One of the things that we're going to be talking about here as we go through this is we're going to be talking about a couple of best practices to make sure that you do this properly and that you're securing yourself to protect yourself against possible fraud and financial damage that can be done with a cloud provider. So our Cloud Slice product requires no trial passes or demo accounts in order to be able to use. These are full accounts that you can utilize for cloud-based training. We currently offer support for Microsoft Azure and Amazon Web Services. It is currently on our roadmap that at some point in 2020, we expect to introduce service for Google Cloud Platform as well. We do support a bring your own subscription model. So if you've already got an Azure subscription or an AWS account, you can bring those to use it. That way, all of your cloud charges are going to be billed directly to you. And then essentially all we're doing is we're orchestrating the management of those accounts for you. This provides direct transient access to the cloud portal. So you use, if you're familiar with the Learn on Demand platform now, you still get to use our IDLX services for lab authoring. Everything looks just like a standard, virtual machine-based lab that you would typically see, except on the left-hand side where the student's actually doing work, it simply uses a web browser and it goes directly into the cloud portal that you're using. We do offer enhanced security controls, which again, we're going to be talking about here in just a few moments. We also support resource templates. We're also going to dive into that a little bit more, but this is going to allow you to provision the cloud account with the exact resources that you need for your lab. Just like our other services, we do support lifecycle actions and scripting. So you can utilize activity-based assessments. You can use performance-based testing if you wanted to create scored labs against these cloud environments. You can also use lifecycle actions so that certain things occur as the lab is being spun up or then possibly as the lab is being torn down. These do fully support hybrid labs. So if you've got a situation where maybe you want a Windows virtual machine where you're providing some software, let's say maybe it's a development-oriented lab for doing Azure cloud development. You can have a Windows 10 box that your user connects to, maybe with Visual Studio pre-installed, all of the Azure libraries and everything that's necessary to do cloud-based development. Your user can then log into that Windows virtual machine and be interacting with the cloud environment. So hybrid is fully supported in this scenario. And one of the things that Cloud Slice offers is immediate teardown of lab resources. So unlike, a traditional lab where you might have to go in, if you were doing this manually, where you would have to go and provision, for 10 students, provision 10 different accounts, get everything in those accounts set up and ready to go for the class, and then manually tear it down. Once a lab starts with Cloud Slice, the required resources are provisioned. And as soon as the lab is over, if it takes the student 45 minutes, they use the resources for 45 minutes. When they click End Lab, all of those resources are immediately torn down and then essentially cleaned so that it can be used for the next student. So you don't have any runaway charges here. So some of the advantages of Cloud Slice is it gives you direct access to a cloud portal. It provides granular security controls for your cloud resources. and it gives you access to a lot of cloud-only services and capabilities that you just wouldn't be able to do in a standard virtualized environment. This can be used for generic cloud training for AWS or Azure. Maybe you want to train on specific cloud services like big data. It's very easy to set up a Cloud Slice account where you can bring up possibly like in a large the Hadoop cluster or Elastic MapReduce or maybe some type of machine learning scenario to have your students work in. And again, it does support hybrid scenarios, so you can also use this for cloud migration training to allow your students or your organization to essentially practice a cloud migration before you go and do it in real time with production resources. So both AWS and Azure really have the same feature sets. There's really only one thing that's a little bit different, and that is with the AWS portal, we support single sign-on so that we can automatically log the user in. No credentials are actually necessary. I'm going to do a demonstration here in a few minutes where we're going to be able to demonstrate this and show you how this works. But one of the reasons, if you have the ability to enable auto login, but it is not required. Maybe you're performing some training, for example, with AWS Identity and Access Management, and you want the user to log in, create an IAM user account, and then log out and be able to log back in. Obviously, in that case, you're having the student practice manually logging into the cloud provider, so you wouldn't want to use auto login. Everything else is pretty much on par between both of the cloud platforms, and they're very, very easy to set up within LOD. So I just got a couple of screenshots here, and again, I'm going to go and do a demonstration of both an AWS lab and an Azure lab so that you can see exactly how these work. But again, what you'll notice here is that your lab instructions still appear on the right-hand side, and then either the Azure or in this case, the AWS console is what the user is going to be working in and working through their lab. So let me go and just do a quick demonstration here. I've actually got a couple of them pulled up, and I'll launch an AWS challenge first. Or actually, I take that back. Let me go ahead and launch an Azure challenge here. So you can see that cloud-based labs are obviously, because we are not waiting the extended amount of time for a virtual machine to spin up, these are very, very quick to come online. You still have the ability to use our replacement tokens in your labs for cloud challenges. Now, as you can see here over on the right-hand side, we just had a notification pop up saying that all resources have now been provisioned. This was a life cycle action. So when our lab started, we executed a script against this cloud resource to, this cloud account to provision the necessary resources that we wanted for the lab. So it's simply a notification. But in this case, I'm just going to copy this username and enter it. And I'll now copy the password and enter it. So these are lab replacement tokens. Obviously, it is going to be different each and every time one of these labs is launched. So that way you don't have to, the user doesn't have to write down, doesn't have to remember all their credentials. But you can see now I'm inside of an actual Azure portal, and now I can go and do my work, right? So I have full control over everything that I need inside of this Azure console or this Azure portal. Let me go and end this one and show you one of the differences. In this case, we're going to go and launch one for AWS, and it looks about the same. It launches in about the same amount of time. So we're talking about a 10-second launch time. Obviously, this is going to vary based on the number of resources that you create when you're building your lab portal, which we're going to discuss here in just a moment. But in this case, you'll notice that I don't have a login and a password, right? The user is automatically logged into the console because auto login is turned on. And now we have the complete AWS console, which I'm going to allow the student to perform lab functions in. So everything else looks just like the standard LODS user interface, right? Now, let's go and take a look at something that's very, very important here, which is securing Cloud Slice. One of the challenges with the cloud is that you have access to an immense amount of resources, right? You've got, for example, virtual machines. You can build virtual machines ranging from one processor and a half gigabyte of RAM to AWS now has servers that have up to 24 terabytes of RAM, 128 processors, right? One of the things, obviously, those are very expensive resources. Well, one of the things that you obviously do not want to do here is you don't want to just open up a cloud portal and give unlimited access to all of the resources in the cloud portal, right? That could be detrimental to your existence, right? People could go in, build any kinds of resources that they want. They can go and spin up machines for possible Bitcoin mining. They could allocate massive amounts of storage and use it for for bad purposes. One of the things that we want to make sure of is that we have the ability to control exactly what services and features of that cloud platform the student can use. And one of the things that we want to do in a best practice here is to use the principle of least privilege. You should only give the user access to the resources that they need specifically to accomplish the task at hand. So in other words, if you're going to have a specific lab that is going to teach the user how to use Azure storage, they should not have any access to build virtual machines or to build Cosmos databases or machine learning. None of that is necessary in order to use storage. So we have a feature called access control policies that we apply and that you have the ability to create custom to apply to your Cloud Slice labs to control permissions within that environment. Now, there is something that is fundamentally different about both AWS and Azure to keep in mind here. In AWS, everything is implicitly denied by default. So nobody has access to do anything unless you explicitly grant them the permission. So with AWS access control policies, you only have to allow them to do something. Azure is a little bit different. Azure is the exact opposite. So you have permission to do everything unless you deny them permission. Well, we have created a baseline template that we ask everybody to use, which kind of reverses that. And I'm going to show you an example of that here in a moment. But what this policy is going to do is it's going to say, allow these features, and if it's anything else, deny it, right? So effectively, it turns it into a deny all policy where you then allow the specific features that you want to use. This is what's going to give you complete control of the resources that can be used in that cloud environment. And it's going to give you much more control over any potential abuse or fraud that can be done with that account. And again, this is something that what most of our authors end up doing is they create a set of baseline templates that they will reuse through their labs. So again, you don't want, it's human nature a lot of times for students to get into a cloud platform and start playing around with other services. So maybe they're learning about Azure storage and they finished their lab a little early and now they're bored, right? So what do? They go start creating databases and they start playing around with big data and playing around with different features of the cloud, which would be great if they were using their own cloud environment, right? Because they're absorbing the charges for this. But when they're doing this in a lab-based environment, you don't want to, to pay for someone's experimentation, because of course, then when the class starts again, do they delete what they created? Right? Usually not. They just abandon it, and it can end up running up excessive charges. Now, we can go and take a look at what these policies look like. So here is a really, really simple Azure policy. As you can see here, if it's not any of these services, it effectively denies it, right? So in this case, we're only allowing the user to perform networking functions. So they could go in and they could create a virtual network. They could create the subnets that they need, but they would not have the ability to do anything else inside of Azure. Sorry, let me just get this out of the way here. A more complicated one in Azure. So here is one that we've actually built for some of our IT Pro challenges that locks down the account pretty heavily. So in this case, you can see that we are allowing the ability to create virtual machines, but we are only allowing these two specific types of virtual machines. You can only create standard D3 and DS3 virtual machines. If you were to try to create any other type of virtual machine that might have excess costs, it's going to deny you access. You can also see here that we're even going to require that the user name the virtual machine VM1, right? Because obviously they should be following the directions in the lab. So they're not going to be able to name the virtual machine, just ad hoc. You can also see that we're even limiting the regions that the user can use. In this case, they can either use East US2 or West US2, right? And it cannot be a global resource. So again, we're steering and we're limiting and putting up guardrails, if you will, to specify what the user can and can't do. AWS, again, is a little bit more simplified because you don't have to put, oops, sorry, I'm trying to use my mouse to scroll here and it's not working. You can also see in this case, obviously, we're giving the user the ability to create networks, create disks. Maybe it's a backup lab, so we want them to use recovery services. But you don't have to put this if-then, this nested then statement that denies the policy. Inside of AWS, that's not it. It's much more simplistic, right? So in this case, if I go and look at a policy, my apologies, I thought I already had it set up here. But here you can see all except EC2 virtual machines. So in this policy, again, everything is denied implicitly, but if anything gets explicitly denied, they can never allow it. So in this case, we're allowing all EC2 functions for virtual machines. However, we are denying the ability to run instances inside of this machine, right? Because in, excuse me, in AWS, this happens to be a networking lab, and the networking features are part of EC2. So again, we want the user to be able to use the networking features, but we don't want them to be able to run EC2 instances. And again, that's where your charges can get racked up, because people start playing around, if you will, with these other services, which is not something that you want to have happen. The next thing that you can use to control your environments are resource templates. These resource templates allow you to pre-provision any necessary resources in a lab for Cloud Slice. So Azure is going to use the Azure Resource Manager, or ARM templates, and AWS is going to support CloudFormation. Both of these are standards within their respective platforms. But essentially what a CloudFormation or an ARM template does is it allows you to execute. It's what the cloud providers call infrastructure as code. So let's say that you have a lab, for example, where the user is going to be building upon a network resource, which is the example that I'm going to show you here. And maybe what you want to do is you want to pre-build some of those resources before they go into the lab. So they have something to work with, right? It's a best practice to use a resource template to provision the resources as a checkpoint for the start of a lab or a class module. I'm sure that most of you can probably remember back in the good old days where you had a set of labs, maybe a 5-day class, and the labs built on each other, right? So day 1 labs had to be done before day 2, before day 3, et cetera, et cetera. Well, what happens if you have a student that maybe missed a module, right? Missed a lab, or for some reason wasn't successful at completing a lab? Maybe they ran into some stumbling block that prevented them from finishing properly. Well, then that's going to block and limit that student from going on to the next module, right? So what you can do here is that you can create these checkpoints. So let's say that you have a student that wants to run module 5 or lab 5. When they click start lab 5, as part of the spin up process, a resource template can be used to create all of the necessary resources to make sure that that environment is in a known state before the student starts the lab, right? Guaranteeing their success. Maybe you have something, you're deploying a web-based application, right? And that's what the lab is. And that web-based application requires a database. But you haven't discussed databases, and you're expecting that the student probably has a DBA, and they just don't know this stuff. You can have the resource template provision that database ahead of time. I can go and show you an example of one of these. So this is an AWS lab. And what this CloudFormation template does, you can see it's a standard text file, right? And again, this is an AWS standard. ARM templates are an Azure standard. So developers for Azure and AWS can use the tools that they have. Many developers even already have CloudFormation templates that they've used in production environments. Those can be brought over to our platform and used as well. So you do get some reusability out of these. But as you can see here, where this particular resource template, when the lab starts, is going to create a VPC. It's going to give it a specific CIDR range. Then it's going to create the necessary subnets inside of that VPC. So every single time this lab starts up, every student is going to have the same base network in which they're going to build their lab on top of. As soon as the cloud slice lab is over, all of these resources will then be torn down. So every single time you end a cloud slice lab, that account goes back to a 0 state or a blank slate, and then can be reused over and over and over again for different students. Now, another thing that we've heard a lot is, what if you just have a web application that you want to train somebody on? Maybe it's an internal, intranet application, or you want to train somebody how to use a software package, but it's just a standard web application. Typically what used to happen is that companies would come to us and they would actually build this web application inside of a virtual machine, right? Which you can still do. If you wanted to have a Windows server where you install the software on it and you want to use a test data set, you can certainly do that. But if it's a production application, if you wanted to teach people how to perform effective Google searches, right? You can't install Google on a Windows server in your environment, right? But Google is publicly available. You can use a web fabric inside of LODS. This works with any web-based application, and it starts literally instantly. So when you go to launch the lab, you're going to get your instructions. You're going to have all the functionality and features of copy and paste and IDLX. Everything is right there, except it is an instant start time. Think of it just as like Cloud Slice. We're provisioning a cloud environment and we're displaying that cloud portal in a web browser on the left-hand side. With our web fabric, we're just going to show that web page on the left-hand side. You can literally train anybody from anywhere on any platform. So the advantages here is it gives you direct access to any web application that you want. There are absolutely no wait times for any kind of lab provisioning. There are no special user requirements at all as long as the user has a web browser. And you can take advantage of all of the LODS IDLX authoring suite features that we have available. This is great for web-based application training or training on any kind of specialized corporate software that you might have inside of your organization. This is one of these features that is often overlooked, but we feel is a really, really powerful tool to help people learn. Right, so here's an example of what this would look like. Again, you see you've got your instructions, your resources, everything that you need, just as you would with any other LODS fabric that you're using, except on the left-hand side, we're just going to be providing you with a web browser, right? So this could be used in a lot of different, for a lot of different scenarios. Pretty much, this is what opens it up. The sky is the limit. You can create training on anything with this platform. Right? So hopefully this kind of gives you an idea of what you can do with these cloud platforms. The cloud in its, by itself is a very, very powerful tool. There are thousands and thousands of features and services that are available in each of the cloud platforms that we support. But again, what we really want, and hopefully you are able to get from this, is that we have spent a considerable amount of time and a lot of trial and error in making sure that you can provision these resources, but at the same time protect yourself by securing those platforms and giving only as needed levels of access so that it can protect you from potential fraud and abuse. And hopefully you can see how you can start building complex cloud-based training scenarios using multiple cloud providers or hybrid training scenarios using the LODS platform. So with that, I want to thank everybody for attending this morning. If you have any questions at all, please feel free to reach out to us at Learn on Demand Systems. We'll be more than happy to discuss your situation. We understand that everybody's needs are unique. We can certainly, discuss, which solution might be right for you and make suggestions. So once again, thank you very much.